This is Professor Needing. Welcome back. We are going to work with DESMOS, and in this particular instance, we're going to work with the difference of means. We're going to find that confidence interval level. We're going to look at that test statistic, and we'll talk about that p-value determination. Our two formulas that we're going to utilize are difference in means for confidence interval level and difference in means for a test statistic. Again, because we're talking about a mean, we're talking about a t-value or a t-score. So we have a question which says, Sophie was curious if her company's jumbo brown eggs and jumbo white eggs had a different weight. She obtained two different independent random samples from jumbo eggs, one for brown, one for white. Here's a summary of the results. So we have a mean value for brown, a mean value for white. We have standard deviation of both sets, and we have a different set size of 490 versus 496. Sophie wants to use the results to carry out a two-sample t-test to determine if the mean weights are significantly different for these types of eggs. Assume that all conditions have been met. Okay, so the first thing we have to do is identify a couple pieces of information we have, write them down, and know that we are going to perform a two-mean test. So I'm going to write down, for instance, that my X bar for my brown is 71.2. I know that also for the same thing as my sigma for my brown is going to be 1.2. And I know that my N value, again, for brown is 490. When I look at my X bar for white eggs, 70.5. I know that my sigma value for those whites is 0.8, a little tighter on the distribution. And the N value for those white, 496. So my first calculation is to utilize the t-test score and calculate a t-test for this given value. So in my formula, my t-test will look like 71.2 minus 70.5 in my numerator. In my denominator, I'll have 1.2 square divided by the set of n. And to that, I will add the second standard deviation of 0.8 square divided by 496. Go to DESMOS in order to make this calculation. So in DESMOS, you can see that I've put in my numerator, put it in parentheses so I could create a fraction. I put the 1.2 also in a parenthesis so I could square it and divide it by 490, and the same with the 0.8 and the 496. My t-score is 10.76, fairly dramatic t-score. So my t-score is 10.76. My next objective would be to measure the p-value of that 10.6. We can almost make the guess that it's going to be basically 0 when we round it, because 10.6 is far removed, and we're testing to the right-hand side of that 10.6. But again, I'll go to DESMOS, and I'll do these calculations. So I will go down to my functions. I will choose a t-distribution. My degrees of freedom, because the smallest set is 490, that means 489 is the degrees of freedom, one smaller than the smallest set. I need to find the cumulative probability. Remember, it's a right side tail test, so my minimum value is 10.76. You can see we have a massively small number. At 1.1 with negative 24, we're going to round our p-value to 0 under all circumstances here. Going back to my value, or going back to my test work, I can now calculate in a rounded statistic that I have a p-value of basically 0 at 3 decimals. So do we have significant evidence? Absolutely, we have significant evidence that the weight of the two are significantly different. If we wanted to calculate a CI for this particular instance, remember that in a CI, we would utilize the difference in the two values, 71.2 minus 70.5. To that, we would add and subtract a t-score. Now, I've already calculated the t-score for you. You will always be given the t-star value. You're not expected to calculate the t-star value. And I gave this at a 95%, which is 1.96. We then multiply that times the first standard deviation square divided by the set of n plus the second standard deviation square divided again by the set of n. And again, I'm going to return to DESMOS in order to make this calculation. I'm going to do a little bit of cut and paste also at the same time, hopefully save you some time. So I'm going to get rid of the distribution. Now notice part of this formula has already been used up here. So I'm going to actually highlight the bottom of this formula, and I'm going to Control C or Control Copy. Now I'll show you why I do that. I'm going to take 71.2. I'm going to subtract 70.5. I'm going to end my parenthesis. I'm going to do the minus first. I'm going to do a negative 1.96. There's my T star. I'm going to hit the times sign in my calculator. Now you can use the times sign here, or you can use the asterisk or the star. They both do the same thing. I need to have, remember, this whole bottom right here. Well, remember, I controlled it. I'm going to paste it in, and here's my first value. I'm going to highlight the entire problem. I'm going to paste the whole problem in, and instead of a minus right here in the center, I'm going to change that to a plus sign. My values here are somewhere between 0.9 and 1.17 for my CI of a 95%. So we could call that 0.9 to 1.2. So my CI is somewhere between 0.9 and 1.2. Now, again, that was a 95%, and you would have to put it into context of the problem. And if we talked about the context of the problems here, then we would have a something to talk about in there. Now, if we take a look at that real quick, remember 71.2 minus 70.5. Those were our two statistics that were taking place. And if you subtract those two numbers from each other, sorry, I was getting my calculator moving on myself, approximately 0.7. And if you look at 0.7, 0.7 falls outside of the range of differences that we just calculated. And remember what we did, under the p-value of 0, we would have rejected the null hypothesis. Why? Well, two reasons. Our p-value is incredibly small, which causes us to reject. Or looking at the CI, the value that we have is outside of the range 0.9 to 1.2, giving us an option for significant evidence in two different venues. Hope this helps you. Check back often and keep up to date.